Breaking tonight, a pattern is emerging along the ancient trade routes of Central Asia that may signal one of the most consequential strategic realignments of the 21st century, and what analysts are tracking is not caravans of silk or spices, but something far more dangerous. For centuries, the Silk Road connected the civilizations of East and West, carrying goods, ideas, and influence across mountains and deserts. Today, a new kind of exchange may be moving along those same corridors, not in open view, but through the gray zones of international commerce, dual-use technology, and defense-industrial cooperation. The relationship between China and Iran has deepened steadily over the past 2 decades, and while much of that relationship is visible in energy deals, infrastructure projects, and diplomatic coordination, there is another dimension that strategists are watching with growing concern. It involves the transfer of technologies, components, and expertise that could accelerate Iran's missile program in ways that reshape the regional balance and force American military planners to confront threats they did not expect to face so soon. This is not a story of confirmed arms smuggling or a secret pipeline of finished weapons. It is a story of what becomes possible when two powers facing parallel strategic pressures find that their interests align, and when the boundaries between civilian commerce and military capability become so blurred that distinguishing one from the other becomes nearly impossible. The framework for this relationship was established long before the headlines of recent years. China's Belt and Road Initiative, launched in 2013, envisioned a network of railways, highways, ports, and pipelines connecting Beijing to markets across Asia, Africa, and Europe. Iran sits at the geographic heart of this vision, the land bridge between Central Asia and the Middle East, and the maritime gateway to the Indian Ocean through the Strait of Hormuz. For China, investing in Iran is not charity, it is strategy. It secures energy supplies, opens trade routes, and creates economic dependencies that translate into political influence. For Iran, Chinese investment offers a lifeline against American sanctions, a source of capital and technology that cannot be easily cut off, and a partnership with a rising great power that shares Tehran's interest in seeing the American-led international order weakened. The economic logic is compelling, the strategic implications are profound, and the military dimension, while less visible, may be the most consequential of all. Iran's missile program has been a central pillar of its national security strategy for decades. Denied access to modern aircraft and armor by sanctions and embargoes, Tehran invested heavily in ballistic and cruise missiles as a cost-effective means of projecting power, deterring aggression, and threatening regional adversaries. The results have been impressive by the standards of a sanctioned economy. Iran possesses one of the largest and most diverse missile arsenals in the Middle East, ranging from short-range rockets capable of striking targets across the Gulf to medium-range ballistic missiles that can reach Israel and beyond. These weapons have been used in combat, tested in exercises, and transferred to proxy forces across the region. They are the backbone of Iran's asymmetric warfare doctrine, the tool that allows a conventionally outmatched power to punch above its weight. But missiles are not simple weapons. They require precision engineering, advanced materials, sophisticated guidance systems, and reliable propulsion. Building them indigenously is difficult even for wealthy nations with robust industrial bases. For Iran, operating under some of the most comprehensive sanctions ever imposed, it should be nearly impossible. Yet Iranian missiles have improved steadily in range, accuracy, and complexity. New designs appear with regularity. Capabilities that were once beyond Tehran's reach are now within it. The question that occupies analysts is not whether Iran has made progress, the question is how. And one increasingly prominent answer points east, toward the industrial and technological powerhouse that has made no secret of its ambition to reshape the global order. China is one of the world's leading missile powers. Its own programs span the full spectrum of capabilities, from tactical short-range systems to intercontinental ballistic missiles capable of striking the United States. Chinese defense firms produce some of the most advanced cruise missiles, anti-ship ballistic missiles, and hypersonic glide vehicles on the planet. Chinese engineers have mastered the technologies that Iran struggles to acquire: solid rocket motors, maneuvering re-entry vehicles, terminal guidance seekers, and composite airframes. The gap between Chinese and Iranian capabilities is vast, but gaps can be narrowed through cooperation, and cooperation does not require the transfer of complete weapon systems to be effective. What analysts fear is a pattern of technology diffusion that operates below the threshold of formal arms transfers. Dual-use components, materials with both civilian and military applications, can be sold under commercial cover and repurposed for missile production. Machine tools used to manufacture automobile parts can be adapted to fabricate rocket motor casings. Chemical precursors used in agriculture can be refined into solid propellants. Navigation chips designed for consumer drones can be integrated into missile guidance systems. The global supply chain is so complex, so interconnected, so poorly monitored at its edges, that controlling these flows is extraordinarily difficult, and China, as the world's manufacturing superpower, sits at the center of that supply chain. The Belt and Road infrastructure itself may facilitate this diffusion in ways that are hard to detect. New railways connecting China to Iran reduce transit times and increase cargo volumes, making it easier to move sensitive materials without attracting attention. Modernized ports on the Iranian coast create entry points for goods that can be dispersed into domestic supply chains before their end use is determined. Joint industrial zones and technology parks, established under the banner of economic development, provide cover for interactions between Chinese and Iranian engineers that may stray into defense-related topics. None of this is proof of a coordinated weapons pipeline, but it is evidence of an environment in which such a pipeline could operate and in which the boundaries between legitimate commerce and military proliferation have become dangerously porous. The missile technologies that may be flowing through these channels are not trivial. Solid fuel rocket motors, which allow missiles to be stored ready to launch for years and fired within minutes, represent a major advance over the liquid-fueled systems that dominated early Iranian designs. Developing reliable solid motors requires expertise in chemical engineering, material science, and precision manufacturing that Iran has struggled to master independently. Yet Iranian solid-fuel missiles have appeared in growing numbers in recent years, with performance characteristics that suggest access to foreign know-how. Chinese solid motor technology is among the most advanced in the world, and Chinese firms have been caught in the past selling related equipment to countries of proliferation concern. The connection is circumstantial but troubling. Guidance systems are another area of concern. Early Iranian missiles were essentially dumb rockets pointed in the general direction of a target and hoping to cause damage somewhere within a wide circle of air. Modern warfare demands precision. A missile that misses by a kilometer is a terror weapon. A missile that misses by 10 meters is a surgical strike tool. Achieving that precision requires inertial navigation systems, satellite guidance terminal seekers, and the software to integrate them all. China operates its own satellite navigation constellation, Beidou, which provides global positioning capabilities independent of the American GPS system. Access to Beidou signals, or to Chinese-designed guidance chips that can process those signals, could significantly improve Iranian missile accuracy without requiring Tehran to develop the underlying technology itself. The scenario in which Chinese navigation support gives Iranian missiles a new level of precision is one that defense analysts take seriously. Maneuvering re-entry vehicles represent perhaps the most alarming potential transfer. Traditional ballistic missiles follow a predictable trajectory after re-entering the atmosphere, making them vulnerable to missile defense interceptors. Maneuvering vehicles can change course during descent, dodging interceptors and complicating targeting. China has deployed advanced maneuvering warheads on several of its missile systems, and has conducted extensive research on hypersonic glide vehicles that combine speed with unpredictable flight paths. Iran has claimed to possess maneuvering re-entry technology, and some of its recent missile tests have shown characteristics consistent with such capabilities. Whether Iran developed this technology independently, acquired it through reverse engineering, or received assistance from foreign partners is unclear. But the timeline of Iranian advances aligns disturbingly with the timeline of Chinese research, and the industrial partnerships that connect the two nations create channels through which knowledge could flow. The cruise missile dimension adds another layer of complexity. Cruise missiles fly at lower altitudes than ballistic missiles, follow terrain-masking flight paths, and can be programmed to strike specific targets with high precision. They are ideal for penetrating defended airspace and attacking high-value targets such as ships, bases, and command centers. Iran has developed an impressive array of cruise missiles, some based on foreign designs and others claimed as indigenous. The Noor, the Qaider, the Hovazeh, and other systems have demonstrated ranges and accuracies that make them serious threats to American and Allied forces in the Gulf. Many of these systems bear design similarities to Chinese cruise missiles, particularly the C-802 and its derivatives, which China has exported widely. Whether these similarities reflect direct transfer, licensed production, or independent reverse engineering is debated, but the cumulative effect is a cruise missile force that is more capable, more numerous, and more difficult to defend against than at any point in the past. Anti-ship ballistic missiles represent a particularly worrying category. These weapons combine the speed and range of ballistic missiles with the ability to target moving ships at sea, a capability that threatens the core of American naval power projection. China has pioneered this technology with its DF-21D and DF-26 missiles, creating what some analysts call a carrier-killer threat that forces U.S. Navy strike groups to operate farther from Chinese shores. Iran has expressed interest in similar capabilities and has tested systems that it claims can target ships. The technical challenges of anti-ship ballistic missiles are formidable, requiring sophisticated target acquisition, mid-course guidance updates, and terminal seekers capable of discriminating ships from decoys in a cluttered maritime environment. China has solved these problems. Iran has not, at least not publicly. But the possibility that Chinese expertise could accelerate Iranian progress in this domain is a scenario that keeps American naval planners awake at night. The hypersonic dimension is the most futuristic and potentially the most destabilizing. Hypersonic weapons, defined as those that fly at least 5 times the speed of sound, can maneuver during flight and are extremely difficult to intercept with existing missile defenses. China has conducted more hypersonic tests than any other nation and has deployed operational systems. The United States is racing to catch up. Iran is far behind, but Iranian officials have made public statements about hypersonic research, and the strategic logic of acquiring such capabilities is compelling. A hypersonic missile that could strike Tel Aviv, Riyadh, or an American carrier in the Gulf would be a game changer, providing Iran with a deterrent that is difficult to counter and impossible to ignore. Whether Iran can achieve this capability independently is doubtful. Whether China would assist is uncertain. But the possibility that technology, expertise, or even components could flow through the networks that already connect the two nations is a risk that cannot be dismissed. What makes this risk more than theoretical is the context of the broader China-Iran relationship. The 25-year cooperation agreement signed in 2021 provides a framework for long-term collaboration that extends far beyond missiles. It covers energy, infrastructure, finance, and security in ways that create deep interdependencies and multiple channels for interaction. Within this framework, military cooperation is explicitly mentioned, including joint exercises, training, and what both sides describe as counterterrorism collaboration. The language is vague, deliberately so, but it creates space for activities that fall short of formal arms transfers while still enhancing Iranian military capabilities. A Chinese advisor helping Iranian engineers improve rocket motor reliability is not selling a missile. A Chinese firm providing software for missile simulation is not exporting a weapons system. But the cumulative effect of many such interactions could be transformative. The economic incentives for China to support Iran's missile program, or at least to turn a blind eye to technology flows that benefit it, are significant. Iran is a major energy supplier to China, and ensuring the stability of that supply requires maintaining influence in Tehran. American pressure on Iran threatens Chinese interests, and supporting Iran's military capabilities is one way to push back. Moreover, the proliferation of advanced missile technology serves China's broader strategic goal of complicating American military operations worldwide. Every additional threat that American forces must plan for, every additional defense system that must be deployed, every additional dollar that must be spent on missile defense is a dollar that cannot be spent on competing with China in the Pacific. From Beijing's perspective, a more capable Iran is a useful distraction, a secondary front that ties down American resources and attention. The risks of this approach from China's perspective are also real. Uncontrolled proliferation could backfire, with Iranian missiles eventually threatening Chinese interests or falling into the hands of non-state actors. A regional war involving Iran could disrupt energy flows that China depends on. And overt Chinese support for Iranian missiles could trigger a more confrontational American response, including sanctions on Chinese entities, military buildup in the region, or even direct conflict. China has historically been cautious about these risks, preferring to support Iran through economic and diplomatic means while keeping military cooperation below the threshold that would provoke a severe American reaction. But as U.S.-China competition intensifies, that caution may erode. If Beijing concludes that the United States is already committed to containing China regardless of its behavior, the incentive to restrain Iranian missile development diminishes. For the United States, the challenge is to disrupt these flows without being able to see them clearly. Sanctions on Iranian missile entities have been extensive but imperfect, with Tehran developing elaborate networks of front companies, transshipment routes, and false end-user certificates to evade controls. Adding Chinese entities to these sanctions lists is complicated by the scale of Sino-American economic interdependence and the risk of retaliation. Military options, from interdiction to preemption, carry enormous escalatory risks and limited effectiveness against the diffuse hidden supply network. Intelligence efforts to map the pipeline, if it exists, are resource-intensive and rarely produce the kind of actionable information that leads to decisive intervention. The result is a policy challenge that has no clean solution, only a range of imperfect options that trade one risk against another. The regional implications of enhanced Iranian missile capabilities are already visible. Israel's missile defense architecture, among the most sophisticated in the world, is designed to intercept incoming threats from Iran and its proxies. But defenses can be overwhelmed by saturation attacks, and every improvement in Iranian missile accuracy or penetration aids increases the pressure on Israeli planners. The Iron Dome, David Sling, and Arrow systems are impressive, but they are not infinite. A scenario in which Iran launches hundreds of missiles in a coordinated barrage, some equipped with decoys, maneuvering warheads, or precision guidance, could stress Israeli defenses to the breaking point. If Chinese technology has contributed to that threat, the strategic calculus for Israel becomes even more dire. The Gulf Arab states face similar dilemmas. Saudi Arabia and the UAE have invested billions in American Patriot and T-HAAD missile defense systems, but these were designed against threats that are now evolving. A missile that can maneuver in terminal phase, that can deploy countermeasures, that can strike with precision rather than area effect, is a missile that existing defenses may struggle to intercept. The attacks on Saudi oil facilities in 2019, using drones and cruise missiles that evaded detection, demonstrated the vulnerability of even well-defended targets to asymmetric strikes. If Iranian missiles become more capable through Chinese support, that vulnerability grows. The Gulf states may respond by investing even more in defense, by seeking their own missile capabilities, or by hedging their bets diplomatically. None of these responses stabilizes the region. The U.S. Navy, as the guarantor of maritime security in the Gulf, faces a threat environment that is becoming more complex by the year. Carrier strike groups, once considered virtually invulnerable, must now plan for anti-ship ballistic missiles, supersonic cruise missiles, and swarm attacks that could come from multiple directions simultaneously. The Aegis combat system, the backbone of American naval air and missile defense, is capable but not omnipotent. Every missile it intercepts is a missile that cannot be replaced instantly. Every ship that is damaged or sunk is a ship that cannot be replaced quickly. And every sailor killed is a political cost that no administration can ignore. If Chinese technology has enhanced the Iranian threat, the margin of safety that American naval commanders have traditionally enjoyed shrinks, and the risks of operating in the Gulf grow. The broader strategic question is whether the United States can afford to fight a two-front competition, one with China in the Pacific and one with a Chinese-supported Iran in the Middle East. American military resources, while vast, are not infinite. The Navy's shipbuilding program is struggling to keep pace with retirement rates. The Air Force is stretched between nuclear modernization, fighter procurement, and drone expansion. The Army is pivoting toward great power conflict after 2 decades of counterinsurgency. And the defense budget, while large, is contested by domestic priorities, debt concerns, and political gridlock. In this environment, every additional threat that requires a response is a threat that diverts resources from somewhere else. A more capable Iran, supported by Chinese technology, does not need to defeat the United States. It merely needs to raise the cost of American engagement to a point where Washington questions whether the commitment is sustainable. What analysts fear is that the Silk Road of the 21st century may become a conduit for strategic technologies that undermine the very order it was supposed to connect. The Belt and Road Initiative was sold as a project of economic development, of shared prosperity, of peaceful integration, but the infrastructure that carries containers of consumer goods can also carry components of weapons. The partnerships that build ports and railways can also build military relationships, and the influence that comes from investment can also come from the provision of capabilities that shift the balance of power. China has not declared war on the United States. Iran has not launched a missile at an American carrier, but the trajectory of their relationship and the technologies that may be flowing through it point toward a future in which both of those things become more possible, more likely, and more dangerous. If this scenario unfolds, the first indication may not be a dramatic attack, but a subtle shift in the intelligence picture. A new Iranian missile test that shows unexpected accuracy. A satellite image of an Iranian facility with equipment that looks suspiciously Chinese. Intercepted communication between Iranian and Chinese engineers discussing technical specifications. These are the breadcrumbs that intelligence analysts follow, the clues that suggest something larger is happening beneath the surface. By the time the full picture emerges, the capabilities may already be deployed, the defenses may already be inadequate, and the options for response may already be limited. The policy response, if there is to be one, must address both the supply and the demand sides of the equation. On the supply side, stronger export controls, more aggressive sanctions enforcement, and better intelligence sharing with allies can raise the costs and risks of technology transfer. On the demand side, addressing the strategic insecurities that drive Iran's missile program through diplomacy, deterrence, or some combination can reduce the incentive for Tehran to seek ever more capable weapons. Neither approach is easy, neither is guaranteed to succeed, but doing nothing, allowing the current trajectory to continue, is a choice with consequences that may be irreversible. This may be less about what has happened and more about what could happen next. The relationship between China and Iran is not a secret conspiracy. It is a public, documented, steadily deepening partnership that serves the interests of both nations. The missile dimension of that relationship is harder to see, harder to prove, and harder to counter. But it is real, it is growing, and it is changing the strategic landscape of the Middle East in ways that will shape the choices available to American policymakers for decades to come. The Silk Road once carried the treasures of the ancient world. Today it may be carrying something far more dangerous, and the world may not know the full cost until it is too late. Tonight, as you watch this, somewhere along the rail lines and shipping lanes that connect east to west, components are moving, expertise is being shared, and capabilities are being built that could alter the balance of power in the most volatile region on Earth. The pipeline is not visible. The weapons are not yet fired, but the risk is real, it is growing, and it is moving closer with every train that crosses the border and every ship that docks in the Gulf. What happens next may depend on whether those who have the most to lose are paying close enough attention to stop it before the first missile launches.